Welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about UVM virtual sequence and virtual sequencer. Now, what do you mean by a virtual sequence? So basically a virtual sequence is a sequence that coordinates and starts other sequences on one or more real sequences. It is typically does not generate or send sequence item directly to the drivers. And whereas in the case of virtual sequencer also, it is a UVM sequencer derived from component that is not connected to any driver and exists mainly to hold the handles or references to multiple underlying sequencers so that virtual sequences can drive them from a central base. So what is this? So previously when we were discussing about your sequence and sequencer in our previous sessions. So if you haven't watched about sequence and sequencer, I recommend you to please go back and rewatch those particular sessions where we have discussed about what do you mean by sequence, what do you mean by sequencer, what do you mean by sequence item. We have an elaborated explanation which is presented. So please, I recommend you to go back and watch those sessions. Okay. Now, so here when we were we were using those particular sequence and sequencer, for example, let me draw that. When I was using a sequence and a simple sequencer, and this sequencer and driver are connected with each other, where your sequence was sending all the sequence items to the sequencer and the sequencer was forwarding it to the driver. This was happening and there was a real connection between your sequencer and driver. So this sequencer and driver are connected with each other using the TLM ports. Using the TLM ports, this sequence and sequencer are connected with each other, and this sequencer and driver are communicating with each other, and sequencer was forwarding the packets which the sequence was sending it to the sequencer. How the sequence was able to find out where is the sequencer is using the M sequencer handle. Using this, we were finding out the sequence can able to find out where is the sequencer is, and it is able to send those particular sequence items to the sequencer. And how it is going to find where it is going to get the M sequencer handle, how the body task is getting executed. This and all things we have discussed in our previous sessions, and this is not the agenda of our this session. Okay, so I'm not going to cover them in detail, that have been already covered in our previous sessions. Now, so this was a scenario which was happening in the previous cases. Now here when we were using this virtual sequence and virtual sequencer, let us try to understand what do you mean by this virtual sequence and what do you mean by this virtual sequencer. Now in the case of virtual sequence, in the case of your virtual sequence, this virtual sequence is nothing but it is like a container which is going to hold all the sequences. Like let's say suppose if we have two sequences, sequence 1, and let's say if we have another sequence, let's say sequence 2. Okay, so this virtual sequence, it is going to hold the sequence handles, that is sequence 1, and if we have multiple sequence, it is going to hold it. Virtual sequence, that particular class, it is going to have the handles of sequence 1 and sequence 2. And what do you mean by virtual sequencer? This virtual sequencer is also a class which is going to hold this virtual sequencer. It is also a class which is going to have the handles of multiple sequencers. Like let's say suppose if in our example we have two sequencers, sequencer 1 and sequencer 2. So this sequencer 1 and sequencer 2 handles are present in our virtual sequencer, whereas in the case of virtual sequence we have sequence 1 and sequence 2 handles which are present in the virtual sequence. Now in our previous example where sequencer was directly connected to the driver, but in this particular example your virtual sequencer is not directly connected to any driver. This is a very important point. So your virtual sequencer is not directly connected to any one of the driver. Your sequencers are connected to your driver, but virtual sequencer, it is just used for holding the multiple sequencers. That's it. It is not going to be connected to any driver. So internally this sequencer 1 will be connected to the corresponding driver, and this sequencer 2 is connected to its corresponding driver. That's it. No virtual sequencer is going to connect to any driver. Okay, so that is what it is written here. So coming to virtual sequencer, it is a UVM sequencer derived component that is not connected to any driver and exists mainly to hold the handles or references to multiple underlying sequencers so that virtual sequences can drive them from a central place. So this virtual sequences so this sequence, so this virtual sequence, what it is going to do, it is going to connect this sequence 1 to this sequencer 1, and this sequence 2 is going to be connected to this sequencer underscore 2. So this is how we are going to use this virtual sequence and virtual sequencer. So this is about your virtual sequence and virtual sequencer. So these are nothing but these are like your containers which are going to, virtual sequences is going to hold your sequence classes, as well as virtual sequencer it is going to hold your sequencer classes. Okay, so virtual sequencer is not connected to any driver or anything. Okay, it is just a holder which is going to hold the instances of your sequencer 1 and sequencer 2. Now why these are used? So let us try to understand. So what are this? We have understood what do you mean by virtual sequence, we have tried to understand, and what do you mean by virtual sequence, we have tried to understand. Now let us try to understand why do we need this virtual sequence and virtual sequencer, and before that we will try to understand why they are called as virtual. Okay, so please remember that UVM will not have any special base class known as your UVM virtual sequence. There is no such class. Okay, please remember this. So in UVM we don't have a class which is known as UVM virtual sequence or UVM virtual sequencer. No, we don't have like this type of classes. So both are just UVM sequence and UVM sequencer. If you want to build your virtual sequence, user defined virtual sequence, you need to extend it from UVM sequence only. And if you want to define your virtual sequencer class, user defined virtual sequencer class, you need to derive it from the UVM sequencer class itself. Okay, there is no such class as UVM virtual sequence or UVM virtual sequencer. No. Okay, you need to derive it from normal UVM sequence and UVM sequencer only. But here we are giving the name virtual to our user defined classes. We are giving the name virtual. Okay, so here that is what it is written as. So both are just UVM sequence and UVM sequencer derivatives in a special pattern, and hence virtual. So why we are using virtual? So the virtual sequencer controls other sequencers. It is not attached to a driver. So if we are using a virtual sequencer, we are basically controlling how the sequencer 1 should communicate with driver 1. So we are basically controlling our sequencer 1 and sequencer 2. But this entire virtual sequencer is not connected to anything. So that's why it is the name virtual. So the virtual sequencer controls other sequencers. It is not attached to a driver and does not process items. It is not going to process any items. Virtual sequencer is not going to process any items. Virtual sequencer, it is not going to be connected to any driver item. It is just used to control other sequences. It is just used to control other sequences. So the virtual sequence coordinates other sequences across multiple sequences, and this virtual sequence job is to coordinate all the sequences to the multiple sequences which we have. Okay, that's why these are known with the term virtual. That's why these are known with the term as virtual. So use a virtual sequencer or virtual sequence when stimulus must be coordinated across multiple agent interfaces in the test bench. So let us see this with an example. So here we have three pictures which are showing. So where in the first picture we can see we have a single driving agent. We have only one single agent. So this is our test class, and inside this we have environment, and inside the environment you have an agent, and inside this agent we have a sequencer and a driver which is connected. So there is only one agent, and there is only one sequencer, and there is only one driver. So in this particular case we don't need any virtual sequencer. Okay, now in the second case, if we have multiple driving agents, we can see there is one agent and this is agent 2. Okay, and this agent 1 is consisting of one sequencer, and this agent 2 is having another sequencer. Okay, now this sequencer is connected to the respective driver. It may be some protocol specific driver, like let's say suppose it may be a UART driver, or it may be I2C driver, or it may be AHB driver, or it may be APB driver. It may be any driver. It is completely dependent upon the protocol. Okay, and here in the agent 2 we have one more driver. It is also protocol specific driver. This may be two different drivers based upon the protocol. Okay, now this sequencer will get the data from one sequence, and this sequencer will also get the data from one sequence. Now, so in this particular case, if we don't need stimulus coordination, then we don't need to use any virtual sequencer. Okay, so in this particular second case, if we don't need any stimulus coordination, then we don't need any virtual sequencer. But if we need the stimulus coordination to be handled carefully, then we use this virtual sequencer. See, so in the case of virtual sequencer, this virtual sequencer is actually consisting of your two sequencer handles. So bus1 underscore sequence, this is this sequencer handle we are containing in the virtual sequencer, and bus2 underscore sequencer2, that is this particular class handle is containing in the virtual sequencer. Now, so this is how we are going to select whether if the stimulus coordination is required, then we are going to use our virtual sequencer, and if stimulus coordination is not required, then we are not going to use any virtual sequencer. So a virtual sequencer, why it is used? Because it can control other sequencers acting as a coordinator rather than a source of item itself. So virtual sequencer, it's not a source, it is just used to control other sequencers, and it is not attached to any driver unlike a normal sequencer, and it has no TLM connection to a driver port, and it does not process sequence item. Instead, it hold the handles to the real sequencers. So the real sequencer handles will be present in the virtual sequencer. And why it is virtual? So UVM does not define special base class, this and all we have seen. Okay, so this is why we are going to use our virtual sequencer. Now let us try to understand briefly what a virtual sequence it is going to do. So basically a virtual sequence, it is a sequence whose job is just to coordinate other sequences. If you want to control, if you have multiple sequences which are present inside your class, and if you want to have a control on multiple sequences, then what you are going to do simply is just declare those sequence handles inside your virtual sequence class. Okay, then you will have a control of you will have a control on the sequences. So the virtual sequence is a sequence whose job is to coordinate other sequences, so potentially across multiple interfaces, often running them in parallel or in defined order. Okay, so it is usually do not create or send any items directly. So virtual sequence, it is also not going to create any item, or it is not going to send anything. Okay, so this is just like a test orchestra where multiple interface scenarios, for example coordinating EPB traffic with Ethernet or PCA by starting the right subsequence on the respective sequences from one place. So this is why we are going to use this virtual sequence and virtual sequencer, just for controlling multiple sequencers and multiple sequence if we have a multi-protocol test bench environment. Now let us try to understand this with an example, like how your virtual sequence is connecting with your virtual sequencer. Everything we will try to understand how we are doing. Now let's consider a scenario where we have two agents. Let's say this is agent 1 and this is agent 2, and this agent 1 is going to have one sequencer. Let's say it is sequencer 1 and one agent, and one driver. Let's say it is driver 1. So let's say this is our agent. Okay, and let's say this particular agent and driver are connected with our TLM ports, and this driver is driving some protocol related data, like let's say suppose UART, it is driving a protocol related data, that is nothing but UART. Okay, and this is our agent 2, and this is our sequencer, and this is our driver, and this is sequencer 2 and this is driver 2, and this driver 2 is driving some protocol specific data, which is nothing but, let's say it is Ethernet. Okay, it is driving Ethernet packets. So this is the connection which we have, and we have an SOC like this, and in this SOC you have a UART IP present, and you have a Ethernet IP which is present. This is our requirement. Now let's say if you are not using any virtual sequence or virtual sequencer, so what you're going to do, so step 1 is to declare your sequence item. So let's say we are not using our virtual sequencer and virtual sequence. So how to establish the connection and how to do it? So we already know that we are going to first declare our sequence item. First of all, declare sequence item. Okay. Now next we need to declare sequencer 1 and inside agent connect your sequencer 1 and driver 1. Okay. Now same declare agent 2 and inside declare and connect sequencer 2 and driver 2. Okay. So this we will do. Okay. So what we are going to do, simply we will write down the class sequencer underscore a, which is extends from UVM underscore sequencer, and the logic which is needed for this sequencer underscore a we will write down, and followed by end class, that we already know. And similarly we will write down the code for our sequencer underscore b, which extends from UVM underscore sequencer and followed by end class. So we have declared our sequencer A class and sequencer B class. Now also we need to declare our sequences also. So how to declare our sequences we already know. Class, let's say sequence underscore A, which extends from UVM underscore sequence. It's a parameterized class. We should provide the parameter whenever we are writing it. That is our sequence item. And the code which we have we will write down here and followed by end class. And we also have another sequence, class sequence underscore b, which extends UVM underscore sequence, and it is also a parameterized class, sequence underscore item. Okay. And it is also end class. So like this we will declare our two sequencers and two sequences. Okay. So I'm following the test bench. Okay. So here we have sequencer 1 and sequencer 2. So this sequencer 1 is connected with one sequence and this sequencer 2 is connected with another sequence. Okay. So I'll write down here. Here we have one sequence 1 and here we have another sequence 2. So this sequence 2 is connected with this sequencer and this sequence is connected with this sequencer. Okay. Now, so how to make that connection? So in the test class we are going to make that particular connection. So in our previous videos also we have seen. So if you haven't watched that, please rewatch that. So class test, which extends UVM underscore test. So here how we are going to establish the connection? First of all, we need to declare the sequence handles. What are the sequence handles which we have? Sequence underscore a, seqa, and sequence underscore b, seqb. So these are the two sequence handles which we have. Now how to make the connection? How we are basically connecting this sequence and this sequencer? So using the start method which we were doing. So in our previous video also I have shown you. Okay. So I need to connect this sequence with my sequencer handle and this sequence with my another sequencer handle. Okay. How I am going to use within my run phase, I am going to write it down. So I am not writing it clearly. So in the run phase, I'm going to make the connection. In the run phase, I'm going to connect this sequence with my sequencer. So how to connect it? So sequence A dot start, and I need to provide the path. So what is the path? It's in environment dot agent 1 dot sequencer 1 is the path. Now this will be allocated to M sequencer and M sequencer will be connected. That and all we have seen in our previous session. Okay. And how we are connecting our sequence B? So sequence B dot start environment dot agent 2 dot sequencer 2. So like this we were establishing our connection, that we already know. Okay. Now let's say if I want to use virtual sequence and virtual sequencer. If I want to use virtual sequence and virtual sequencer. How to use them? So let us see. Let us try to understand. So how to declare first of all your virtual sequence? Virtual sequence can be simply declared as class virtual underscore sequence. It's just a name, it's not a keyword, it's just a user defined name. We are just using the keyword virtual because it's a sequence, but it is not at all connected to any other sequence. Okay, that's why we are using the keyword virtual, okay, which is extending from UVM sequence, and it's a parameterized class. We need to provide the parameter sequence underscore item. And in the virtual sequence, we are going to have, we should declare both sequence handles as well as sequencer handles. So our sequence handles, let's say what is the sequence handle which is present here? Sequence underscore a. Sequence underscore a, let's say seqa, and another is sequence underscore b, seqb. And also we should declare our sequencer handles. So what is our sequencer handle? So the sequencer handle which is present here is seqr underscore a is our sequencer class name. seqr underscore a, let's say it's as sa or sra, and seqr underscore b, srb is our sequencer handles which we have declared here. Now, so this is our virtual sequence class which we have declared. Okay, now let me also declare the virtual sequencer class, and I will come back to the virtual sequence again. So let me declare the virtual sequencer class. So in the virtual sequencer, what I'm going to do, virtual sequencer extends UVM underscore sequencer, and it is also a parameterized UVM underscore sequencer. Now, so I will register everything I will do, and inside this virtual sequencer I will have the sequencer class handles seqr underscore a, seqr underscore a, sra, and seqr underscore b, srb. So these are my sequencer class handles which I have declared in my virtual sequencer, and followed by end class and something class virtual underscore sequencer. So this is my template for my virtual sequencer. It is going to have your sequencer class handles and sequencer A class handle and sequencer B class handle, and it will have a new function, okay, and registering logic that will have. Okay, this is our sequencer class. So I will draw it with the block diagram how it is going to look like. So this is my, what I have done is I have declared my virtual sequence class where I am having sequence 1 and sequence 2, and this is my virtual sequencer where I am having sequencer 1 and sequencer 2 present here. Now I need to connect this sequence 1 with this sequencer 1, and I need to connect this sequence 2 with the sequencer 2. I need to start sequence 1 on this sequencer 1, and I need to start sequence 2 on my sequencer 2. Now, how to start this sequence 1 on this sequencer 1 and how to start this sequence 2 on this sequencer 2? Let us try to understand. Now, previously what we were doing in the test class, we will just simply calling the start method, right? So let us see how we are calling the start method. So in the test class, let me show you where it is, the test class which has written in the previous example. Yes, this one. So in the test class, in the previous example where there is no virtual sequencer and no virtual sequence, what we were doing, we were calling sequence A dot start and we are providing the path, and sequence B dot start and we were providing the path. Now when we are not using this virtual sequence and virtual sequencer concept, we are calling the sequence A dot start and we are calling environment, we are providing the path, and we are using sequence B handle and we are calling the start method and we are providing the path. So this is the case where we are not using no virtual sequence and sequencer, where we are not using no virtual sequence and sequencer. But if I want to use virtual sequence and sequencer, then how to write the code in the test, that we will see. So when we are using this virtual sequence and sequencer, first I have declared all the virtual sequence and all the virtual sequences which are needed, and inside my test class what I am going to do is class test, which extends my UVM underscore test. What I am going to do, I am going to first of all declare my virtual sequence handle, virtual underscore sequence v sequence. So this is my virtual sequence class handle v sequence. Now in the run phase, using this virtual sequence handle, what I'm going to do, v sequence dot start. So I'm using this virtual sequence handle, virtual sequence class handle dot start, and I'm providing the path environment dot, and I will also declare my virtual sequencer handle also, virtual underscore sequencer, that is v sequencer. So what I'm doing, v sequence dot start environment dot v sequencer, v sequencer. So basically I'm trying to start my virtual sequence on a virtual sequencer, and if you observe, this virtual sequence is also extended from UVM sequence. So this virtual sequence is going to have a handle of m sequencer. This is going to have a handle of m sequencer, and this m sequencer this m sequencer is of which type class handle? So this m sequencer is of which type handle? It is of virtual sequencer handle. This m sequencer here, it is nothing but it is our virtual sequencer handle. So using this start method, what we are doing, this virtual sequence is going to know where exactly is your virtual sequencer. So previous example also, what we were doing when we were not using our virtual sequence and virtual sequencer, so when we are starting our sequence a dot start, and when we are providing this path, then the m sequencer which was present inside our sequence class, the m sequencer handle which was present inside our sequence class is now able to know exactly where the sequencer was. Okay, so the sequencer, this path is copied to this m sequencer, so that's the sequence will come to know, okay, where exactly is the sequencer one was. And here also, thus when we are calling the start method, this m sequencer is copied to this path is copied to this m sequencer handle, and this sequence underscore b will come to know, okay, where exactly is this sequencer underscore 2 is. Now here when we are using this virtual sequence and virtual sequencer, here also we are doing the same thing, but what we are doing, we are not taking the individual sequences, we are taking the virtual sequences. So virtual sequence class dot start of, and what we are passing the path, what is the path, environment dot virtual sequencer. That is, now this virtual sequence will come to know where is the virtual sequencer which is present. So the m sequencer, it is nothing but it is the handle of our virtual sequencer which is present inside our virtual sequence. So this is how we are establishing the connection between our virtual sequence and virtual sequencer. Now inside this particular virtual sequence class which we have declared, where we have declared, here we have declared our virtual sequence class. Now inside this virtual sequence class, we need to write down a body task. We need to write down the body task inside our virtual sequence class. We are going to write down the body task. And what is the body task we are going to do? First of all, we are going to create the, so inside our virtual sequence, we need to declare our environment handle, environment env underscore h, because virtual sequence is not it's a standalone class, right? It's not present in any hierarchy. So we need to have this environment handle, and we need to declare the instances of our two sequences. What is our sequences? Sequence A, sequence B. We need to create the instances of our sequence A, and we need to also create the instances of my sequence B. We need to create the instance. We need to create the instances of my sequence A, and we need to create the instance of my sequence B. After creating the instances of sequence A and sequence B inside my virtual sequence, what I'm doing, I'm calling the start method using the sequence A dot start, and on which it should start the sequence. So I should provide the path. What is the path? Environment dot virtual sequencer dot sequencer is the path I should provide. and here sequence underscore b dot start of environment dot v underscore sequencer dot sequencer underscore b. So inside my virtual sequence class, and I am again calling the start method, and I am starting sequence A on the sequencer, and I am starting my sequence B on the sequencer. And how this sequence is connected to sequencer underscore A, how this sequencer underscore B is connected to sequencer underscore B, how it is utilizing the M underscore sequencer handle, that and all we have discussed in a very detailed manner in our previous session. If you haven't watched them, please go and rewatch them. So this is how we are establishing the connection between our sequence A and sequencer underscore A, and sequence B and sequence underscore B using our virtual sequence. So nowhere in the test class I haven't used my sequence A handle and I'm starting on sequencer 1, and nowhere I have started my sequence 2 on my sequencer 2. So everything I am writing inside my virtual sequence class. Okay, now, so this is how I am establishing the connection between my sequence and sequencer A and sequence B and sequencer underscore B. Now, so there is one more handle. Now, till now we have used only one handle, which is nothing but our M sequencer. So this is nothing but our sequencer class handle. It is our sequencer. This is what we have used. Now, there is one more handle which is known as P underscore sequencer. So there is one more handle which is known as P underscore sequencer. So basically this M underscore sequencer, it is a predefined handle, and whereas this P underscore sequencer, we need to define it. We need to define this P underscore sequencer. Now, how to define this P underscore sequencer? So we can simply define this P underscore sequencer UVM underscore declare underscore P underscore sequencer, and we need to provide the handle name which we are using, P underscore SCQR. So what is this? What is happening if we are declaring this P underscore sequencer? So internally what happens is a typecasting will be happening, and this M sequencer will be typecasted into this P underscore sequencer. So first of all, type checking will be happening, and typecasting. So this particular handle will be typecasted into, so this particular handle will be casted into P underscore sequencer. This handle will be casted into P underscore sequencer. Now, what is the use of using this P underscore sequencer? So let us try to understand. So in this particular previous example where we are using the virtual sequence and virtual sequencer, we were not using P underscore sequencer, right? Now let us try to use this P underscore sequencer, and let us see what is happening. So let me erase this particular line. So this line is when we are using this, when we are not using the P underscore sequencer. Now, when we are trying to use our P underscore sequencer, first of all, when we use this macro and when we declare our P sequencer handle, then this M sequencer will be typecasted to this P sequencer. So whatever the M sequencer handle, to which sequencer it is pointing to the same thing this P underscore sequencer will be pointing out, right? Now in the test class, when we are calling this virtual sequence dot start of environment dot virtual sequencer, we already know this M sequencer is having the path that is nothing but environment dot virtual underscore sequencer. M sequencer is having the path that is nothing but environment dot v sequencer. So that means this P sequencer is also having this particular path. Okay. Now, since we know that P sequencer is having the same path, now in the virtual sequence class, instead of writing the whole path inside the virtual sequence class, the body method of this virtual sequence, instead of writing the whole path, what we can do, we can simply use P underscore sequencer dot the sequencer handle, sequencer underscore A, P underscore sequencer dot sequencer underscore B. That's it. So this is how we can use our P sequencer handle. If you are not using your P sequencer handle, we are going to specify all the path. But if you are using your P sequencer handle, you need not to specify the path, since you are calling your vsequence.start of environment.vsequencer. So msequencer is having the path that will be casted in, that is also pointed by your p-sequencer. So inside your virtual sequence body task, you can use simply p-sequencer. Okay, that is how you are going to use your virtual sequence and virtual sequencer. Now let me summarize this whole discussion. So without virtual sequence and without virtual sequencer, inside your test class, you need to start your sequence underscore a, and you should provide the path for sequencer. And inside your sequence underscore b dot start, you should provide the path for your sequencer 2. This is without virtual sequencer and virtual sequence. Now if we are using with virtual sequence and sequencer, then inside your test class there is no need to use this sequence A handle, sequence B handle. Just use the virtual sequence handle dot start, and you just provide the path to virtual sequencer. That's it. There is no need to provide the path for entire sequencers. Just provide the path to virtual sequencer. Now inside the body of virtual sequence, inside the body of your virtual sequence, what you need to do inside your body of your virtual sequence, you need to again call the start method. Okay, how you are going to call the start method? So sequence 1 dot start of the path to the sequencer, and sequence 2 dot start and path to the sequencer. Inside your test class, you're not starting one sequence onto another sequencer. Inside your virtual sequence class, you are going to call sequence 1 on one sequencer and sequence 2 dot another sequencer. Okay, whereas when you're not using the virtual sequence and virtual sequencer, you are calling sequence A on one sequencer and calling sequence B on another sequencer in the test only. But when you are using virtual sequence and virtual sequencer, you are calling this inside your virtual sequence. So inside your test class, what you should do, vsequence dot start, you need to mention the path to the virtual sequencer. Okay, so that and also what you should do, you should declare your p-sequencer handle, so that the path which you have mentioned here, that will be copied to msequencer, and further it will be casted to your p-sequencer. Okay, now inside body of your virtual sequence, what is happening? So you are using sequence 1 and you're calling the start method, and instead of providing the whole path, you can just use p-sequencer dot sequencer 1, and you can use sequence 2 dot start p-sequencer dot sequencer 2. That's it. So this is how you can use this p-sequencer. So that's about your virtual sequence, virtual sequencer, and p-sequencer, m-sequencer. Yes, so these are all about your virtual sequence and virtual sequencer. So in our next session, we will try to understand this with a coding example, and we will try to build this virtual sequence, virtual sequencer, and we will try to communicate with virtual sequence and virtual sequencer. Okay, and the driver. Okay, how this particular things are happening. Let us try to understand this with a coding example in our next session. So if you have any doubts or any queries, please feel free to comment in the comment section, so that I can come to know where you're not understanding any particular concept, right? So I hope I have tried my level best to clear about this, to make you clear about this particular concept of virtual sequence and virtual sequencer. Yes, so that's all about this video. If you like this video, please like, share and subscribe to my YouTube channel, all about VLSI. Thank you for watching this video.